Hi everyone, welcome to Summer Code, the Python course. We're talking about Chapter 5 and logic today. Some announcements first. We have workshops every day at 7 o'clock. The slide says 7:30, that's incorrect. The purpose of the workshops is to improve your code, to talk about best practices, clarify past subjects, and today's section will cover functions, iterations, and variables. Some other announcements. There's no class Monday, July 4th. And the best way to find out what the course schedule is to go to the main page for the course, click on course schedule, log in apparently, and as you can see on July 4th, there's no class. All right. Additionally, if there's no seats, or at least no seats where you can easily see the presentation, find Jesse and he'll find you a seat. We just want to make sure that seats go in the right places, and if you need any extra chairs, he can get them for you. All right, first we're going to start talking about Booleans. Now, a Boolean is a value that can be true or false, and just one or the other. And what this gives us power to do is use Boolean expressions to compare numbers and find out if something is true or not. So some comparison operators that you'll come across are the strict equality, which is the double equal sign here. And the difference between a single equal sign and a double is that the single is assignment. So if you say A equals B, that would set A's value to the value of B, whereas the double equal sign returns a value of true if they're the same and false otherwise. Similarly, you have the not equal sign, which means that it's true if they're not equal and false if they are. And then you have the other relations, that is that A can be less than B, or A is less than or equal to B, meaning that it's only true if A is less than B, and A could also be equal to B in this case, and that would also be true, and vice versa for the greater than. Okay, so if you look at these three options, the first one here, 1 equals 1, that's definitely true. Now how true does not equal false? That, despite having booleans in it, evaluates to a boolean in the end and is in fact true. Now 1 greater than 3, that will return false. Now a single expression by itself wouldn't be that interesting, but Python lets you combine multiple expressions into a greater expression, and it does so by two keywords, and or. And is special because it will join if both of them are true and will result in true. If either expression is false, it returns false. Or on the other hand, says if one of them is true, it returns true as a whole. In fact, you can use a little trick called short-circuiting, where if A is less than B, it won't even try to check B is less than C, because it knows that half of it's already true, and that's all it needs to say that the whole expression is true. That can be useful later on. All right. Now, because you start combining things, you have to understand the order at which things combine. It can get more confusing if you have lots of different expressions and see how things combine together. This is similar to the PEMDAS order of operations that you saw in high school algebra. This is power, parentheses, exponents, multiply, divide, add, subtract. The same kind of thing applies to Python, and in fact, in the book they have a link that'll take you to the full outline of how all of the order of operation goes. But in this case below, this entire expression, you're going to first go through, do the multiplications, or in this case the parentheses. So you can say x plus 3, and then that quantity times 3, and check to see if that equals 0. And then 3 times x plus 3 and check to see if that equals 0. And then you're going to use the or. So it's the logical combiners at the end that are always happen at the end. You can always make things clear by putting parentheses, which will be very helpful if you want to make a particular operation or set of operations specific. All right, now what really makes these powerful is that you can use them in conditions. That is, you can have one piece of code that happens if a condition is true, and if it's not, you have another piece of code. And so the simplest we run into is an if-else condition. If the condition here is true, it does this do something right here, whatever that might be, whatever that block contains. Now, if it's not true, the else happens. Now, exactly one of these must happen, um, because the condition can be either just true or false. There's not a third option. So one of these must occur. Now, with that, it's called a binary selector because you only have two options. It's binary is in the sense of two. Um, and what that looks like in the flow control diagram is if you go through, you hit your condition. If it evaluates to false, you hit statement 2 and you continue on. If it comes out true, you hit statement 1 and it goes on and continues. That is, there's only two paths and one of the statements must occur. Now, perhaps you don't want two things to occur. You want one to occur if the condition is true. In that case, you can just omit the else. That is, here's an example here. If x equals 10, you can check to see x, does it in fact equal 10? And then we'll print x, which would be 10 in this case, and then done. If x did not equal 10, it would just bypass this entirely. Again, you can see that in the flow control diagram. If the condition is true, you do the statements. If not, you just continue on your merry way. All right, now conditionals form a let me rephrase that. Any conditional can contain a block of code inside it. Now that block of code really doesn't have any restrictions. You can have any code that you want inside. So in this example, if x is greater than 0, you run this entire block of code right here. Now that block happens to also include another conditional. This kind of structure can be really helpful if you have multiple decisions being made. It basically makes like a tree diagram of decisions. That is, you go through and you say, if x is greater than 0, then I want to then expose this y to another conditional, which then does something independent of that. And of course, you can have the follow through logic to say, well, if it's not this, if x is not greater than 0, then you can print not greater than 0, and none of this block will execute at all, so nothing here will print, even the else. Another form that's incredibly helpful is the chained conditionals, and that introduces the new keyword called elif, which is just a shortening of else if. Other languages will actually write out else if, so if you see that, it's the same thing. And the rule here is that one of these will run. If x is greater than 0, it will print this. If x is less than 10, it'll print this. And if those both fail, then it hits the else case. Now, the important thing here is that one of these conditions must occur, but only one will. If x is greater than 10, it'll do this. If x is less than 10, it'll do this, and so on and so forth. Only one of these will ever happen. If one of the conditions overlaps, and say you said if x is greater than 0, and here you said if x is greater than 10, and x was 11, this first one would occur, but then it would pop out to the very end. You won't run multiple of the substatements unless you break them up into separate cases. In this one, only one will occur at a time. A Boolean function is a special kind of function, and we talked about functions before. A function is any group of code that takes arguments and then returns something at the end. Now, even if you don't exclude something, remember it returns none, but in this case what we want is something that returns a Boolean. That is, the function returns true or false, and only true or false. Which brings us to our pre-studio. So what we're going to go over is how to write a function called any, which tells me if any Booleans in the list are true. Now, this is very important. This is a very important kind of function. You run into this all the time. Perhaps you say, well, did anything in this, did any test succeed? Is any user logged in? And you could go through an entire list of those values from your users who are logged in or such, and get a value for, yes, is there someone logged in or not, or anything of that particular variety. So we'll open up our Scratchpad really fast. All right, so let's start by making a list. Let's call it list of bools. And we can have a true, false, and a false. Okay, so let's call this function any. And we define a function by starting with def, and let's give it that kind of a form. Let's add a docstring that says return true if any item in the list is true, false, otherwise. Okay, let's make this a little bit bigger. We'll fill in some room there. All right, so because we're going to want to check every single thing on the list, we want to loop over every possible value and then check it. So we'll do that with the for loop, and we'll say for x. X is not generally a great idea to use, but since it's such a small context, it's really obvious what x represents. And if you use too long of a variable name, it could obfuscate what you're really trying to accomplish. Okay, so what this will do is it'll pick out each value in the list, assign it to x, and then run the following block of code. So I'm going to say if x is in fact true, I want to return true. Now it was suggested before that I could do an else here and say return false. The problem with this though is that on the first one, if the first element is not true, it'll return false. But what if I had the case where I have a false at the beginning and a true in the middle? This would fail because it wouldn't catch the second one. It would immediately return false. So let's drop that for now. So this will work for the true case, if there's any trues. But what if it goes through the entire list and it does not find a single one that equals true? Well, in that case, we just want to return false. So let's test this out. Excellent, it's true, and if I get rid of this, I should get false. Excellent, there we go, a really simple implementation of any. This little spot right here, I'm going to put a comment, could just be x. And if x was true, then it would trigger this. However, if you're not sure every argument in your list is in fact a bool, you could have another setup like this, perhaps if, let's say 2, and then print 2 is true. Let's rerun this. 2 is in fact a true value. And that's for some compatibility with other stuff and some paradigms. 0 is not true. But we can talk about more of that later. It's just to be compatible with other languages which use only numbers and don't have explicit Boolean values like Python does. There are other languages that don't let you do that, where they say only Boolean values can be used as conditionals. But Python is a little bit more flexible, so you can do a little bit more of that. Excellent. If you have any questions, be sure to ask me. Thanks for watching.